This meeting is being recorded.
So good morning, everyone. My name is Chaincode, and I'm from IBMC blockchain team. And today's webinar is going to be provided by Tomasz Opałko from IBM Blockchain Poland delivery team. And he is going to talk about Chaincode best practices. But instead of me talking about the details, I will leave the introduction and the content to Tomasz. So yeah, Tomasz, the stage is yours.
Okay, thank you, and hello everyone. First of all, thank you very much for joining this webinar, and I would like to also express my thanks to Maciej for inviting me to talk to you about some of my experiences as a smart contract developer. First of all, as Maciej has already mentioned, I work for IBM Poland in a blockchain team. I've been with IBM for 13 years now. And I've been working on smart contract development for now it's I think almost 3 years. So the topic of today's presentation is basically some tips on smart contract development for Hyperledger Fabric solutions. I would like to share, as I mentioned, my experience, some practical information, but I'm not going to show you any code, mainly because, as you probably know, Hyperledger Fabric allows you to develop your smart contracts in several different languages. My preferred language of choice is Golang, but I suppose it's not as popular JavaScript or Java, so your experiences may vary. I decided to concentrate on main points on designing the contracts so that they perform as good as possible and that they are able to be deployed to production, because there is a huge difference between contracts used in proof of concept solutions and the things that end up on production servers. So I think that this might be of interest to many of you, hopefully. Okay. I've decided to cover several topics. As you can see, the first one will be the word state. And then I would like to talk about data models, about private data collections, some aspects of business security in your smart contracts, and some issues that may come up when you try to integrate with other systems and other smart contracts. Okay, as to the word state. As you might already know, the Hyperledger Fabric gives you the choice of your word state database. This can be either a level DB or a CouchDB. The main difference is that the level DB is just a key value store, so you can access data by performing queries on basically just keys. And in case of CouchDB, you are able to make rich queries for the values, for the data itself, because this is a JSON document store. And there is also this practical difference that level DB is, let's say, incorporated into the peer container, and the CouchDB is a separate container. It needs to be deployed on the side of the peer. So that's the main differences. And of course, the fact that the CouchDB is a JSON document store means that your code will be maybe quite different from the basic level DB case, because you will be able to do much more in terms of accessing your data, performing queries, filtering, and such. And I will talk about this in a moment. Very important aspect of managing your word state, your data, is the way how you structure your keys and how you keep your data in your database. In case this is particularly important in case of FlevelDB, because you cannot perform query on data. So if you want to achieve some sort of filtering or selectors, you have to organize your keys in a way that will enable you to do that. And the composite key is a concept that allows you to store the data using a key constructed of several parts. There are dedicated APIs for handling those keys. I'm prepared some very basic examples. Let's assume that we are talking about some virtual, hypothetical, I don't know, car sharing company that is, for example, storing the data of its vehicles. So the basic APIs that you can use, I'm giving you the example of Golang, but this is the same in other languages. I mean, the concept is the same. The functions may be called differently, but it's of no importance. So, as you can see, you can have a number of ways of constructing such keys, but I would recommend to use, first of all, to use a prefix, which will enable you to distinguish the type of your data. And then you can have several key parts. As you can see on the right, we have an example of an invoice data, of vehicle data, and also a different object that I called just a checkup. It means, let's say, a technical check of a car, of a vehicle, and the key is constructed from not only the key of the car, the identifier of the car, this is 123 in this case, and also the date of the checkup. Obviously, you may construct it any way you want. I mean, put any data you think necessary into the key. In this case, I've decided to present it to you like this. As you can see, so the checkup, we have the vehicle and vehicle plus 123. The 123 is the identifier of the key, and the checkup has now two values, two parts of the key: the identifier of the vehicle and the date the checkup was performed. Okay, so you can access the data in several ways, either by direct query, you just provide the key, like get state, or if you want to perform some sort of a query on the data that are structurized in this way, you can use different functions. You can get state by partial composite key, which means if you provide just the prefix as an argument to such a call, you will get all objects with the prefix vehicle. So in your case, this means all the car data that you wanted. Of course, you will receive an array of objects in return, and you have to iterate over it. You can also provide a different part of the composite key. I mean, the prefix plus some other elements of the key. However, you need to remember that you can only start from the left and go to the right. I mean, you can query by checkup plus the first part of the key, which is this vehicle identifier in this case, but you cannot query by checkup plus the date. So you have to go in strict order when you provide the parts of the composite key. So as this example illustrates, if you provide just the prefix plus the vehicle identifier, you will have all checkups of the car with ID 123. This is, of course, a very simple example, but I hope it illustrates this idea well. And there is also a way to query the data by range. So if you have some keys that are structured in a way that you can distinguish a sort of a range of values, it's possible to get just a part of it of that set of the keys by providing lower and upper limits to a range. As this example illustrates, if you if you want to return all checkups of a vehicle 1, 2, 3 in 2020, you can perform query get state by range and provide the identifiers just that the part that is being iterated against is the date. This is the last part of the key of the composite key. This is possible only in case if the key well, if it makes sense, if you have some sort of value that can be iterated. If you just use unique identifiers for the keys, such a query well wouldn't make much sense. But it all depends on your business case, on the way you structure the keys. So sometimes it can be helpful. You can query, get the data with pagination, and then there is an API to limit the number of objects that you get in return. And it works, of course, for the retrieval by partial composite key and by range. And one more, I hope, interesting thing is that you can construct and split the composite keys in your code. Namely, if you have a query which returns an array of objects, which means an array of keys, you can extract some data from the key itself by splitting it, and then use it further for processing. Sometimes it's helpful, especially if you have some, let's say, mirror keys with different prefixes. I will talk about this in a moment. So that's the first part, the composite keys. I'm talking so much about it because it's you can use it both in LevelDB and CouchDB word states. And in case of LevelDB, basically this is the only thing that you can use. So if you have an architecture, a solution that doesn't use CouchDB, you may overcome some limitations by being clever in approaching the key idea. And you don't have to resolve to rich queries. This is sometimes helpful if you want to create some sort of, both LevelDB and CouchDB are not relational databases, but sometimes you need to preserve this sort of relationship between objects, especially if this is many-to-many, and it's possible to work with that by having a good set of composite keys, a good design. Okay, and now going to CouchDB, you are able to perform also rich queries on the data, on the content. As I mentioned, the data that you store is usually JSON because this is a document database. And in this case, the Fabric gives you much many options. You can query. You can use selectors. You can limit the number of fields that are going to be returned from the database. You can perform some sorting, and you can see there are concepts such as selectors, such as array of fields to return. This is basically stuff that comes from CouchDB. So Hyperledger Fabric is just using it. You can find a lot of practical details in CouchDB documentation. However, there are some limitations that I will mention in a moment. So you need to be careful about that as well. I have provided a very simple example. You have let's say that you have a car, which is some identifier, and this is stored as part of the key. But also you just have the value, the business data of that car. And now the data, we store them as JSON, and we can see that we have a type, we have a make, we have a year, some colors, some mileage, and we also have the identifier. This is something that I'm pointing out because sometimes we can face something that I call data redundancy, which means that you already have the information about the identifier stored in the key. But sometimes, so storing this as well in the value may be redundant. But sometimes it's worth having it already into places, especially if you have to iterate over arrays and avoid splitting the composite key and extracting the data from there. So it's up to you. Have to decide if the information that is going to be duplicated basically in the database is either small enough or important enough that justifies such approach. So it's up to you and depends obviously on your business case. But going back to the queries, so we can use selectors. In order to use selector, obviously we need to have a field with a name defined in our object. In this case, this is the type. And if we perform such queries, we also should have indexes. As we can see here, we have an index of on two fields, on type and of year. Year is used because we may want to perform a query which is sorted by this field, and therefore we need to include it in the index. If we do not define our index, well, the performance will be way slower. So I advise you on using that. However, you need to remember that the more indexes you have, the more performance impact there will be as well, because indexes are recalculated on each new block. So you have to be aware that this is going to take some time. So as I mentioned, you should have indexes, but not too many. I mean, you have to carefully consider your data model, your business functions, and the way you access your data, and try to work out, let's say, a plan for the query so that you can reuse them as much as possible and have as few indexes as virtually possible. But still, they are needed. There is also a hint. You can limit the number of fields that you get back from the database into into the smart contract for further processing. It makes sense if you do not want to transfer larger objects between the CouchDB and the smart contract. Basically, it saves you network load, and also processing resources if you have some larger data sets. And so you can use this filter on fields. As for the limitations, you have to be aware that some operators, such as operands as or, in, or regular expression, will cause the full scan of the database. In that case, your indexes will be useless. So it's better to avoid such solutions. Sometimes I think it's more beneficial to just get the larger data set from the database and iterate on the smart contract side. But obviously it depends on the business case. Also, well, it's helpful to test your queries during the development phase just by logging into CouchDB user interface and then work with the query editor and perform some test runs just there before writing programming them into your code. But you have to be aware that there are some things that CouchDB is able to do, but smart contracts cannot use. Such things are, for example, aggregation functions, and there is also no pagination for transactions. Not the queries. And you have to be aware that if you extract some data during transaction, there is no execution of the data set during validation phase, which means that sometimes you can end up with a bit different result, which is something we do not want, definitely. So you have to be careful when making such queries in transactions. Okay, so I have already mentioned the data redundancy. Okay. So let's go to the data models. Data models is something that may have a very big impact on the performance of your smart contract. And there are several factors that you need to take into consideration when designing your model. And I said data models because you may, and I suggest that you have not just one, but even a number of the models, and I will explain in a moment. But first, I'd like to talk about those design factors. So the first factor, obviously, is the database type, because well, if you have LevelDB, you have to put more effort into constructing the composite keys. In case of CouchDB, obviously, you can switch that effort into constructing your queries and indexes. So that's the search criteria, the second factor. Very important thing is to understand how your objects relate to each other in your database. So you have to somehow keep in mind that both LevelDB and CouchDB are not relational databases, but obviously we need to store the relations as well. So this is about the careful design of those objects. So that, for instance, you don't have like one big JSON embedded with several different logical objects embedded in it and stored in one key. And if you want to access just a simple part and a small embedded object inside, you have to retrieve the whole big JSON, this whole big object. So this is to be avoided. As I call this object decomposition. I mean, you store smaller parts like this building blocks as separate objects under separate keys, but they are related. And this relation can be achieved by, for example, having composite keys with common first part. Just let's say the last identifiers may differ, or the object that is related can have one more section of the composite key at the end. So it's up to you. Okay, and another factor that you have to consider is object size. And I do not necessarily mean that this is a JSON which has many fields, but just literally, if you are forced to store a large object, I don't know, even a PDF scan of some document, obviously this is not the best solution, and I would rather suggest that you do not do that. You do not store documents inside Hyperledger Fabric. But if you have some sort of data that needs to be stored and it's quite large, but it's accompanied by some metadata, you can split the data into two objects, and for example have just let's say the binary part, which would be, let's say, for instance, a PDF. But again, I'm not encouraging you to do that. So you can have that large object stored under one key, and then all the metadata under another. And depending on your business case, it's quite possible that there will be a very limited number of cases when you have to retrieve this large document, this large part. And on the other hand, you can have quite many calls to get just the metadata. In that case, it's beneficial to have it just stored as under separate key. And do not have to retrieve everything as a huge data set. So that's the object size. And also there is the issue of change frequency. Some objects may change more often than another. Or you can have one object and let's say, well, whatever it is, it can be, let's say we have a car. The car has this mileage attribute, which says how many kilometers the car has already run. So we can imagine that things such as the make, the year the car was manufactured in, the model, they are not going to change basically at all. But this one attribute is prone to frequent changes, more frequent changes. In that case, you might consider splitting the car object, vehicle object, into two smaller objects, one with, I don't know, constant, and the other with, I don't know, details or status or whatever it is. So it's up to you. But this is also a case when you should take this into account. And the last but not least, we have the issue of data ownership. And I mean, this is the question of who owns the data, who provides the data, and who has and should have access to it, both as a reader and as writer. In that case, this is a factor that impacts well data location, and by that I mean whether to store this in the blockchain itself, or perhaps in private data collection, which by definition limits the access to a number of members who are private to the data. Okay, so those are the factors that you should take into consideration when designing your data models. As for the models, this is my suggestion, but it worked quite well in a number of projects that I have already been involved in. To have separate data models for the ledger. So the objects that go directly into the storage, whether into the blockchain or the private data collection, it doesn't matter. This is just let's say this is your backend, your internal data model that is the core of your smart contract. You can have a look. I have provided a few examples. This is basically the same stuff that we have already seen on the previous slides. We have a model for vehicle, for a checkup. And also the third object is something that, as I mentioned, if you are forced to have some binary data like a scan, whatever, you can split the checkup. That would be certificate of I don't know, of checkup proof that it worked and it was well, and someone actually has performed it at all. Okay, so this is the ledger model, but obviously the smart contract is going to provide some data to the outside and to receive some data from the outside. In that case, it will be invoked by some external system, some API, whatever you are going to build on top of that. And in that case, it's beneficial to have a different model, transport model, for exchanging the data with the external world in both directions. Why this is beneficial? Because sometimes you have to be, you are forced to change something in the definition, or the external system wants to send you something else, some more data for, I don't know, to have additional validation, whatever. And in that case, it's better to have a separate model just for that communication. and do not mix some let's say, I don't know, technical details or data that is related only to the communication part with the business data that you actually want to have kept stored in the blockchain. So on the right, I have provided some, let's say we have a function that returns the data of the cars. So we get cars sorted. In this case, you just have sort order and a flag for providing checkup data. Obviously, you do not have anything like that in your data model that you store in the ledger, but having it in the transport model gives you a clean definition of the functions of the data that's going in request and in response. So just, I call them just wrapper objects for each business function that you have defined in your smart contract. I strongly suggest you have them defined on the side. Also, as you can see, response to this function returns an array of completely different objects. This is the car information, but also checkup information. So the data is put together from two objects that you store in the ledger, from the vehicle and from the checkup. And having the separate model for that gives it flexibility. You just need to construct the return object, the response object in your smart contract. But this keeps your code clean and the model easily understandable and maintainable. So I encourage you to go this way. Okay. Now about the private data collections. They provide a way to separate data. You can also separate them by storing data in different channels, but this has a different implication. Sometimes having different channels make no sense, and you just need to limit access to certain data to certain groups or organizations. You define the private data collection by providing some basic information. It needs a name, it needs a policy, and the policy is the most important thing, because it says who will be able to access the data. And there are some other technical details. The one that I find quite important also is as a block to leave, because this means whether the data will be automatically deleted after some time, after a number of blocks has already been added to the blockchain or not. So maybe this is not strictly about code code development, but it's important to keep that in mind so that you are not surprised one day when your query doesn't return anything where it should. So that was just a short introduction, but about the actual way the data is stored. Well, it's private, so it's put in a separate storage, separate part of the word state that is called private state. While the hash of the data is just put in the ledger in the blockchain. Write sets are also written separately in private write set storage, so they do not end up in the blockchain. And one thing that's quite important is to use transit field if you want to pass some private data. If you want to pass data that you don't want to end up in the blockchain, because everything that's sent as transit is, let's say, it's skipped. It's not written into the write set. It's into the blockchain. Okay, so when you are working with private data collections, there are some useful tips that help. Well, if you store your data in the ledger and you query it, you will have an array of objects returned. That's obvious, and the same works for private data. So sometimes, I mean, you have to perform a separate query to get let's say to get corresponding objects from the private data collection. By that I mean, for example, if you have an object, some business object describing, for instance, the checkup. Sometimes you need to separate the business, the private part of this object from the public one. One of the most obvious reasons is maybe the GDPR sometimes, but also just some data may be limited to just a number of organizations or the owners that are going to see it. And in this example that I have prepared, maybe not the best example, but hopefully it will explain everything. We have this checkup. The part that is public is the check type, the result, some details. Nothing private, nothing dangerous here. But also there is the private part that contains the personal data, name of the technician who performed the checkup. That's an example, but let's assume that this is private for some reason. So, the thing that worked quite well for me in the smart contract that I have developed was to store the same, I mean, to have the object split into two parts, the private and the public. Use exactly the same keys, composite keys to store it. The point is, the private part is stored in the separate space, in the private data, private store. So you can use the same key, and obviously it will not overwrite the part that is stored in the blockchain, the public part. So one thing is the mirror key. So use the same keys for both private and public objects, provided that you go with this approach, obviously, to have a business object split into two parts. And another thing is you can, let's say, mirror query parameters. It may work in most cases, but I'm sure that sometimes it's not worth the hassle. But what I mean is, if you perform a ranged query or a query by partial composite key, and you receive an array of checkups, a larger data set with several thousands of objects, and you run it first on, let's say, the ledger part. You have an array, but only this is just half of the data that you need. So you have to get the other half from the private data collection. And now there are several approaches to getting the matching data from the PDC. First of all, you can just iterate over the first array of the array of the public parts. And when you iterate, you have access to the key and the value. So you can just take the key just as it is and perform get state. So direct call to the data that's stored in PDC, and retrieve just this one piece of data using the key. But you have to to call it as many times as you have the objects in the first array. So that's something that sometimes it's not very, let's say, very optimal from a performance perspective. And sometimes it's easier, I mean, it's faster to perform a matching query on the private data collection. The point is, a query performed like this, well, obviously it will be a query on data. So if you want to have a matching set, you have to use the same field and the same value to query on. And the problem with this might be that normally you wouldn't store the result in the private data collection, because first of all it's not private, and second, you already have this data in the public part. But for the sake of, let's say, of such a of simplification of such match, you may put it as well in this part, okay, maybe the result from business perspective, that's not the best example. It might be something else, like identifier of some, I don't know, parent object, whatever it is. But that would mean that you run exactly the same query on the same parameters into databases, basically. The public part from the ledger and the private from the PDC. And in that case, you would have two matching arrays, and you can just match the objects by array index. So this is something that also it works. It may be helpful in a number of cases, not everywhere. You just have to figure out what's faster and what's easier for you, depending on your business case, obviously. Okay. And now, yeah, private data collections are very handy. They provide a nice functionality of limiting data access, but you have to be careful, especially in case of transactions, because you may end up in a situation when you just cannot access some data and cannot therefore endorse a transaction. I call this a data gap. And well, this is for example, if you perform a query on a data set and you do not know exactly which peer is going to execute this query, you may end up with a peer that doesn't have access to the data. This is more like a client-side problem. I mean, on the side of the API invoking your smart contract. So this is not exactly inside your code, but you have to be aware that your smart contract can be executed on a peer that doesn't belong to the private data collection. And then you have to plan on what happens then. I mean, whether you will just return an error, or perhaps you can handle it in a different way, because it's possible to access just the hash programmatically from the code, and for example, compare it with something that came in the request. So there are ways around this. It's obviously dependent on the business case. But query is one thing. The more important thing is transactions. Okay. What I want to point out is that when you store the data for the first time, it can be stored in the PDC. I mean, such a transaction can be endorsed also by peers that do not have access to the PDC. They will put only the hash in their own word state, and the peers that belong to the PDC, they will store the whole object. This means that you are still able to have endorsement even if some peers do not have access to private data collection, which is good. But you have to be aware that sometimes when you perform transactions, you may rely on data that should already be there in the private data collection, and you need to retrieve it, to check something, validate, whatever, change value, and store it again. And in that case, you have a problem, because obviously your smart contract cannot access the data if you don't have the private data collection. I mean, if the peer that is running the smart contract does not belong to this collection. This is also about very careful planning. And sometimes you just have to redesign your logic. You have to perhaps shift some of it to the client side, even though you don't have the extended transactions. You have to be careful and consider everything in a great detail. Also, there is one more problem, one more limitation. If you have a transaction which retrieves data from private data collection, and let's say that your smart contract, that the peer that's running it, is a member of that collection, so there is no problem with well, not having access to the data. let's assume that this is not the situation. Just a regular member of the PDC. You have to be careful when querying and then trying to write the data, because Hyperledger Fabric has this limitation that if you perform a query by value, so not you do not retrieve data by key or composite key, but just run query, you then cannot modify the data in the same transaction. There will be an error, and this is by design, because as I mentioned, the queries are not re-executed during revalidation phase, and you can end up with some data inconsistencies. Therefore, this has been, let's say, disabled. So we have to be careful about that. Okay. As for the business security, well, obviously, if you run a smart contract in a production environment, you need to provide some sort of security. There are several, let's say, layers on which you can work with that. First of all, as a developer, you can introduce some checks inside your code, smart contract code. You can check client certificate. I have provided some functions from Golang, but I'm pretty sure there are some equivalents in Java and JavaScript as well. So you can just parse the client certificate, and you can, if you look at the picture at the bottom side, this is the first point of control. Let's say your API, your client will have to provide some sort of certificate, client certificate, to be able to connect at all. So if you are using TLS, it's all the better for you, and you can parse the certificate inside your smart contract. Then you can extract information like common name, organization, also some X509 extensions. So well, you have the APIs for that. I mean, you have the libraries and dedicated functions to work with that. And it's up to you what you want to, let's say, to base your logic on. It's even possible that you may want to limit access to certain business functions or data to only certain organizations, but not by checking, well, who is mentioned in this common name of the client certificate. So it's up to you. You can adjust it to match the business needs. Also, you can go one step further. You can just develop a number of functions that will check not only, as I said, the certificate, but also, well, some custom access control list, whatever you decide to design. You can pass, for example, user information like, I don't know, username and role, just inside your request payload. And then check the access inside your smart contract. The access can be limited by, as I said, by roles, or even for some reason to certain users. It's up to you. And obviously, only after validation has been performed and the check was successful, you can retrieve the data from the ledger, from the private data collection, and work further with that. So then that's one thing that you can do. So you can code it, and also you can make your smart contract more secure by design. And by that I mean, for instance, you can use transient data to ensure that things that you do not want to store in the blockchain, they will not be saved anywhere. That's what the transient field is for. And it may be helpful if you are passing, for example, some, I don't know, private personal data that shouldn't be stored in the blockchain. This is particularly useful in case you have some, let's say, GDPR questions, issues. So this is transaction data. Also, you should well consider where your data is going to be stored. I mean, stored and how it's going to be separated, so that, for instance, certain organizations cannot see it and others can. For that, you can just have different channels or use private data collections with proper policies to match your business cases. You can also encrypt the data. It's a bit more complex. And there are some things that you should keep in mind, namely, well, you should encrypt it before storing, obviously, because you do not want to store any keys in the blockchain, private keys. If needed, you obviously may store some public certificates. It's up to you, but definitely do not store private keys in blockchain because they will stay there forever. Also, whenever encrypting anything, you have to keep in mind that your crypto material or key certificates are going to expire one day, probably. I mean, in production environment, it's rather sooner than later, but obviously it's up to you and your design. And of course, they may be also revoked. So you have to ensure that once you store something encrypted, you are able to decrypt it later and use the data. Otherwise, they're lost forever. This is something that you have to be aware of. Okay. And the last but not least is integration. And by that, I mean interaction of your smart contract with either external systems or just your client API and with other smart contracts, because well, you don't need to have only one. You may have several that exchange data with each other. But there are some things that you have to keep in mind when designing your smart contract integration. First of all, and the most important thing, I think, is having deterministic results. So to make sure that whenever your smart contract is providing is calculating some endorsement, it's always the same on each peer. Otherwise, you won't be able to successfully finalize a transaction. So you have to be careful about using random values, timestamps and such. So you should not generate anything like that inside your smart contract. It should be provided from outside. So your client API should send it. Also, you have to be careful about those let's say data gaps that result from some nodes not having access to private data. I have talked already about this in the private data collection part. And also, I was quite surprised, but well, I learned something new. Sometimes the language that you are using for your smart contract also imposes some limitations on the implementation. Like in case of Golang, well, I found out that if you iterate over a range is so like an array, let's say. If you can iterate over an array in several ways, and one of those ways, which is quite useful and quite nice to code, has this drawback that it doesn't iterate in a deterministic way. So the order may be different on each pass. Sometimes it's of no importance, especially if you just perform query and do not change any data. But in case of transactions, especially if you have a loop and you iterate and you have to break at some point, you do not know which element is going to be. I mean, how many elements are going to be read before that break? And as a result, you may end up with different read sets, for instance. And obviously, there will be no endorsement for such a transaction. So this is something to keep in mind. I'm not aware of JavaScript or Java problems like that, but I would be surprised if there weren't any. So you have to like find out for yourselves. And also, in case of, let's say, offchain processing, if you rely on data from external systems, well, it's very dangerous because you have to ensure that each peer that's providing the endorsement ends up with the same value from the external system. So you can either, let's say, implement some sort of Oracle services which will provide this consistency, or you can just try to detect duplicates for a transaction. Okay, but you have to be very careful when interacting with external systems. As for smart contract interactions, well, it works if you have, let's say, quite a large smart contract with multiple objects and multiple functions, and you also have to invoke a different one. Well, I have worked with something that I call, let's say, web service approach, which means if I have two smart contracts that interact with each other, I design a set of very small, let's say, minimalistic data models and functions that handle only the data that's going to be exchanged between those smart contracts. So I have, as I said, dedicated data models. I have a set of server-side functions and client-side functions. I mean, obviously, they are both inside smart contracts. One is in one, and let's say the server is in the provider part, and the client is in the other smart contract. This is just for simplicity, for let's say, for better managing the scope and the logic. You obviously do not have to do that, but it really helps me personally, and I encourage you to try this. Also, you have to keep in mind that if you have any sort of security implemented in your smart contract, you should have also plan on securing the calls that come from, let's say, from the same node but different smart contract. In that case, you may have different roles, different users, different levels of data access, but still you should consider it and code it accordingly. Just a short example, if you, for example, if you have a normal smart contract that provides I already mentioned now car information, we have the car sorted request. This is the regular function that is sending the data to the outside world. We have a request response. Sometimes you may need to, let's say, to have a subset of the data retrieved by a different smart contract. I don't know, let's say for audit purposes or some reporting. I do not know, but just an example. In that case, it's using the regular business functions with larger data set returned and with more, let's say, more parameters may not make such sense and may provide unnecessary load on the processing node. So sometimes it's just easier to have a smaller dedicated function with smaller data set with different model. Of course, I suggest that you name those functions in a different way, also the object models, so that they don't get mixed up. Okay, so I think that's it from my side. I hope it was interesting, and well, I'm not sure if we have any time for questions, but if we do, then go for it.
Thank you, Tomasz. You provided a wealth of information about all of the aspects that developers have to take into account while designing and developing Chaincode in Hyperledger Fabric. And we have a number of questions. However, we reached the top of the hour. So my suggestion is as follows. I will copy the transcript of all of the questions and I will post it on LinkedIn together with the video as well as the presentation from today's session. And once it's going to be published, then I invite you to answer to all of the questions, because we have some really interesting stuff in there. It's just that we would need another hour in order to dig in through all of these. So this is my suggestion. Feel free to follow us on LinkedIn once the recording is going to be placed. We will post all of the questions there, and we are also going to look for more questions to which we will try to answer throughout the week. So my proposal now is to wrap up the session. Again, thank you very much for attending and for your time. We are looking forward to hearing you and having a possibility to show you some new stuff next week, next Wednesday at 10 a.m. Central European time. And yeah, stay safe and have a nice day. Looking forward to seeing you. Bye-bye.
Okay, thank you. Bye.